Dear students, can you see the screen?
Yes.
Yes,
Yes,
Professor.
yes,
Yes,
sir.
we
Now
can
I
see
can
the
see the
Yes.
screen.
screen, sir.
Okay.
Yeah.
So as we are describing the function which is a mapping from A to B, and A is called the domain set and B is referred to be the codomain set of F. And we can also define the relation as A cross B in the form of that, where A is element of the domain and B is from the codomain set. There is a two thing. One is the codomain and one is the range of F. So range of F is the entire set, and the like for example, F is a mapping from let me write a mapping. For instance, if this is the example, if we describe like this, F is a mapping from say R to R, the set of real numbers to set of real numbers. And this example, if we defined as f of x equal to x square plus 1. Now, note that uh, here we can see what about the domain set and what about the range set of that one. So, if we put any real number, we will get again some real number. And that real number is actually the again the we can get the real number. So it means that the domain of this f is equal to the r, like the set of all real number is domain. And what about the codomain? If we say this is domain of f, if we just like write the domain of f and the codomain of f is equal to, can someone tell me what is the codomain of this set? Like if we put any real number, for example, the positive or negative. So remember that at 0, the answer is 1. And if we put -1, the answer is the 2. And similarly up to so on. So it means it cannot be negative and it will be always 1 and greater than the entry. So it means the codomain of this function is the all entries which are from 1 up to the infinity. So this is the codomain of f. And another thing is range of f. And the range of f is actually, since the function is defined from R to R, so this set R or this set B is called the range of f. So just we mentioned this is R, but remember that in the both sides there are R. So this is the domain set, this is the range set, but the codomain is the collection of all possible entries where f gives us its image or f give us the element from this set. For instance, remember that if we put the 0, the answer is 1. And if we put the 1, the answer is 2, and all collections of that. But it will not be gives the negative. It will be always the all entries are from to the infinity. So these are the domain, codomain, and the range of f. On the other hand, if we define another function, like if we have the two sets like if we put the values over here and we will get some distinct entries of this one. For instance, x equal to 1 to 3, y is equal to 4, 6, and 9, and f defined f be defined as this one. This is the relation between that, and one can note that if we put the domain value 1, we will get some answer which is the 2 times 1 plus 2, which is equal to the 4. And if we put f as a 2 in that one, we will get some value like 4 plus 2, which is equal to the 6. And if we put the third domain value 3, the answer is 8. But remember that this 8 does not belongs to the y, because the y is the this does not belongs to the y, because y obtains only the values which are the 4, 6, and 9. So it means this is a relation which is not a function. We define this one. So here we can say that the, the relation f is f from the a from x to y is not a function. So because the function must be the well defined on each of the values from the domain set and the range set. So in this case, it's not a function because it's give us some value which are outside from the range set. And remember that the function is also the well defined on each value of x. If we have some values, for example, at 3, if the function is not defined, then it means this is not a function from x to the y. So these are the relations regarding the functions. And one can also write the entries in a set of order pairs, as we can say that it's right into the form of a and b. So remember that the entries of the domain and the entries from the range we can define in this way. Like we know the cos function is f of x equal to the cos x, and the values of cos x is always in between 0 and minus 1 and 1. So we can write these relations in the form of a relation like a time cos of a, where a is coming from the r. And similarly, we can also define this relation that x comma 300x, like in the form of order pair. So we can get such kind of relations between that. Similarly, here, since we obtain the all positive values, so x which are strictly greater than 0, x comma log of x. If you write into the pair form like this one, x comma log of x over, and for this we can write the x comma 300 times x. So these will becomes the order pairs, and this is the another way to show the relation of a function. And the range or set or image set we already described. The image set is actually the collection of all those values of a b in a set b, in a set range set b, where b is equal to f of a. And here we can consider the function one. There is this function is defined on the 1, 2, 3, 4, 5, 6. So we can define the image set like the domain set is the set having the entries 1, 2, 3, 4, 5, 6. And remember that these the first entry will never can be repeated, because on one value the function cannot give us the two answers. The range entries can be repeated, and the image set of that one is the 2, 3, 5, and minus 1. And just write like minus 1, 2, 3, and 5 in this way. So we can describe the two sets of for a function. Okay. So furthermore, we can define function on some particular set S, and that is called the image set of S. And there are the some examples of that one. And also we can find the inverse image of some set T, and it is the collection of all those A belongs to the A, where f of A belongs to the T. So these are the ways or relations for which we can define the entries over there. And the next thing is about the like we can find some determine some images of some set S for a function, for a given function f. So this is also the way to define a set, like all those real numbers which are greater, which are for which 9 is less than and equal to x square, and the functions are available over there. So here what we can do is first we need to be describe this about the sets, like here the image set of the function. Like if we need to give the value of some function, suppose f is defined from r to r plus. R plus means collection of all non-negative real numbers, like from 0 to infinity, where 0 is also the element of set r plus. Now, if we take f of x equal to e raised power x, So we need to give the image set of this set S. So let us see that here we need to find out all those real numbers where 0 is less than x square minus 9. So from this relation, we can take that 9 is less than equal to x square. So it means if we need to identify for what values the 9 will be less than equal to x square. So this will give us the three all those x which are greater than 3 and all those x which are less than minus 3. So it means S is the set coming from minus infinity to the 3, minus 3, where minus 3 is included, union 3 to infinity, where 3 is also included. So this is the set S. Now we need to identify the image for that set. So since this function is increasing and we just put the values like the first value is the minus 3. If we put the minus 3 over here, so it will becomes e raised power minus 3. And the function will gives us the e power 3 at f f of 3 is e raised power 3. So we just identify the values like this one. So it means that the image set of S is f of S uh, minus infinity to e raised power minus 3 union e raised power 3 to infinity. And similarly, for the function, if we take this function, for the function gx equal to 2x plus 1. So we need to see that what is the value of a function g at this minus 3. If we put minus 3 over here, then we can see the value like which is equal to minus 6 plus 1. So it will becomes minus 5. And also the value g at the plus 3 because the other value of s is starting from the plus 3. So if we put plus 3 over here, we will get the the value 7 in the range set. So it means that g of s, the image set of s on g is uh, minus infinity to minus 5 union 7 to the infinity. And this is also the way that we can define the inverse image of f on set S. So inverse image is also the way to compute the inverse of a function. For instance, if we need to identify the inverse image of this function f of x equal to 2x minus 1 on this set S, which is the collection of all those element where x square minus 4 is greater than 0. And remember that we can write this set like for all those values where x square is greater than 4 or the entries from which are greater than and equal to 2 and less than equal to the minus 2. So this is our set S. Now we need to obtain the all those values for which f inverse of S, like all those real number where f of x belongs to the S. Now when f of x belongs to the S, f of x is equal to 2 minus 1. And if we take 2x minus 1 is less than equal to minus 2 because the left hand side is containing all those elements which are less than minus 2. On the other hand side, we obtain all those entries of a function which are greater than or equal to plus 2. Now, if we solve this equation for x and we can get the value of x, like all it gives us all those values of f which are less than or equal to minus 2 and the all those values of a x which are greater than 3 by 2. Now, if we make this as a combine this as a set for this collection, then this will becomes the inverse image of a f on set S. So which is equal to the collection of all those all negative entries from minus infinity to the plus square plus 1 by 2 union 3 by 2 to infinity. And now after these values and also we had some example regarding the inverse image of some set T. So these are available over here. Then the next thing is that when two functions are equal. the two functions are said to be equal when they gives the for which f of a is equal to g of a for all a belongs to the a. Like the function values will be remain same at each entry of that one. So these are some examples. For instance, if we take uh, f of a is equal to 2a square minus a, and g is a function also from z to z defined as g of z equal to x times 2x minus 1. Now notice that for each value of a belongs to the z, f of a is equal to the g of a. So this means that this function is fulfill this definition, and hence this function is a these two functions are equal. Then the next thing is about the composition of a function. If f is a mapping from, or f is a function from a to b, and g is a function from b to c, then we can produce, or we can define another function h from uh, a to c. So this function is basically the composition of the function, and we can see some example regarding that one. For instance, f is a function from a to b, and the g is a function from, and g is a function from b to c. Then we can define another function which is called the composition function of a GOF. If we take x coming from to the a, then we need to apply the f on it. If we apply the f on this one, then it will give us f of x. And remember that f of x is give us the entry on the set B. And so if when it will give us the entry from a B, then it means we can apply the G on that. Now, if we apply the G on that one, so G of f of x gives us G of y, because f of x we say equal to y, where uh, the y is the element of a set B. Now, G of y is equal to some z, where z is coming from the C, because the g of g, if we apply g on b, we will get the element on set c, and hence it means the uh, this h is a basically equal to uh, GOF. We say that in this way, and hence h is a function from a to c, and we can see an example for this one, like f of x equal to 2x plus 1, and g of x is defined as x square. And we need to be compute the two things. One is the FOG of x and GOF of x. So these are the two functions we can compute, and we can also show that they are unequal. But important thing is that here we need to define the functions, like f is a function from set of real numbers to the set of real number, uh, defined as this way, and the g is a function from set of all real numbers to the set of all non-negative real numbers r plus, because the second function we call it as a g is a function, and defined in this way, this one. So now when we have the two functions, we can compute FOG of x and GOF of x, and we can show that the both values are unequal in this case. And the composition is simple for this. For instance, if we compute the FOG of x, then it means apply f, but first need to apply the g on x, because g is on the right hand side. So first apply the g on that, and when its image will come, so then apply the f on this. So for any x coming from the set of real number, we are applying the g first. So if you apply the g first, then it will gives us x square. because G is defined that G of x equal to x square for each real number x. Now, if we apply f on x square, so f is defined as f of x equal to x 2x plus 1, then 2x square will becomes 2x square plus 1. So this is basically the f of g of x. Now, we can compute the g o f of x. If we compute g o f of x, so g will remain same. First need to apply the f on some element x. So this when we apply f, so f is apply from the set of real numbers. So here we can see that this is equal to g, and if we apply f and on any x, the image will be equal to 2x plus 1. So this will becomes 2x plus 1. And when we apply the g on 2x plus 1, remember that g of x equal to x square. So it means it will becomes 2x plus 1 whole square. Now we have the two different outputs because we notice that f of g of x is equal to 2x square plus 1, g o f of x equal to 2x square plus 1, and remember that both are not equal because one is the whole square and the other is without the whole square. For instance, if we put the 1 on the both, like at 1 this will gives us 3, and at 1 this will gives us 3 square, which is 9. So 3 is not equal to 9. It means that these maps are not compute. So we can see that we can mention here as FOG of x is not equal to, they are unequal. The values are not equal to GO f of x for all x coming from the domain set of FOG and GOF. Hence, we can conclude that the FOG is the composition of a FOG is not equal to the GO of F. So this is basically the relation between these. Now, the next thing is the one function and onto function. The function from uh, A to B is said to be the one function whenever if we take any two distinct entries A and B where A is not equal to B, it follows that f of A1 is not equal to f of A2. Like A1 is not equal to A2 implies f of A1 is not equal to f of A2. And this relation can be also shows another of its equivalent form. For instance, yes. For instance, we can identify this like if we take f of A1 is equal to f of A2 implies that A1 is equal to A2. We can uh, also write its equivalent form, or if we take f of A1 is equal to the f of A2, then we get A1 is equal to the A2. So if the function satisfy the either first condition or second condition, then we say that this function is 1, 1. On the other hand, the a function is said to be onto if for each entry from B set, the range set, there exists at least one element A in A such that f of A is equal to B. Means in this case, the range set is equal to the codomain set of F. Both will be the equal. If this has happened, then we say that such a function is onto. For instance, if we will see on the uppercase, here we have some functions. Uh, f of x equal to x square plus 1. Note that the codomain set is the 1 to infinity, but the range set of f is complete R. So codomain of f is not equal to range of f. It means this function is not onto. Why? Because remember that in range set we have also the zero. In the range set, zero is also available in the range set. But there does not exist any element in the domain set of this R for whose image is the zero. Like if we put whatever the value from the range set, we will never get the zero. So it means that we get the several elements for which there does not exist any element in set of a domain. So it means the codomain set of F is not equal to the range set of F. So that's why we say that such a function is not onto. So here I can also mention that in this case, the codomain of F is equal to the range set of F. Like they both will be equal to codomain set of F is equal to the range set of F. And here if f is both 1, 1 and onto, then we say that such a function f is the 1, 1 correspondence and also called the bijection between the two set A and B. For instance, here this is the above example. So this function is not 1, 1 and not onto. For example, one can see that if we take the two distinct entries like 1 and minus 1, remember that 1 and minus 1 are unequal, but g of 1 is equal to g of minus 1. So it doesn't fulfill this relation. So that means we conclude that such a function g is not 1, 1 function. And why this function is not onto? Remember that this range set is the set of all real numbers. So minus 2 belongs to the range set of f. If we say that this is the range is range set R's minus 2 is belongs to the range set, but there does not exist any A in R whose image is minus 2. Like whatever we put over here, the function is defined in this way. So is the least value of this function is minus 1, but not minus 2. The minus 1 will be only on the 0. So this gives us the thing that this function is not onto. Now, on the another example, if we see that if f is a function from R to R defined as f of x equal to 2x, this function is 1, 1. We can see that if we take any two real number for which f of a is equal to f of b, then this implies that the f of a is 2a plus 1, f of b is 2b plus 1. This implies 1, 1 can be cancelled from the both side and 2 is a positive real number. So 2 can also be cancelled or divide from the both sides. So this implies A is equal to B. Now it means that for any AB, whenever we take f of A equal to f of B, then it will give us A equal to B. Hence this function is 1, 1. And this function is onto, for instance, if we take any entry in the in the range set B, there exists an element A in the domain set of R such that f of A is equal to the B. So this function is onto, and therefore such f is 1, 1 correspondence. Now if we define a function in another example, h is a function. This h is a function defined as f of x equal to x square. Note that this function is not onto, so because uh, for there is no value in domain set whose image is minus 1 or whose image is minus 2 or minus 3, so this function is not onto. So if a function is either not 1, 1 or onto, then we can conclude that that function is not a 1, 1 function. Now here we can compute the inverse of a function. For a function, say f of x equal to 2x, we can find f inverse. For example, for this case, just take y is equal to 2x plus 1 and solve this function as a x equal to as a f of y. So if we take y equal to f of x and compute it for y is equal to f of x. So remember that we can write this as a y minus 1 equal to 2x, and this implies x equal to y minus 1 by 2. So this y minus 1 by 2 will becomes as a it will becomes as a x equal to say f of y in this form. Then this will becomes the inverse function of a given function f, and hence we conclude that f inverse of x equal to x minus 1 by 2. And remember that if a function is 1, 1 and onto, then the inverse function of f exists. And when the inverse function of f exists, then f and f inverse, f o f inverse is same as f inverse o f. Like this computing relation will always exist in that case. So this is the example we already seen that one. And so here we can also see about the function. Suppose that f is a function defined from the set of real numbers to the set of complex number, where the elements are in the form of a real part and the imaginary part. So now notice that the range of R is the all those complex number whose modulus equal to 1, because you remember that the all entries of the range sort of S is the cos x minus iota sin x, and when you take its absolute, the conjugate, the modulus of that one, so f uh, the z bar is equal to the 1. And on the other thing, the f of 0 is equal to the cos of 0 minus iota sine 0, which is equal to cos of 0, and cos of 0 is 1. And also the f of 2 pi is also equal to 1. And remember, this means that the function is repeating its values on the entries of a domain. So f of 0 is same as f of 2 uh, pi, where 0 is not equal to 2 pi. This means that this function is not a injective. Injective means this function is not a 1, 1. So this function is not 1, 1. And surjective is another way of the name, which is called onto. This function is not also not onto, because in the complex entries we have also the 2, and but there is no 2 belongs to the f of x, or in the range set of f. And then there are, we have seen this one. This is also some lessons about the functions when they are 1, 1 and onto. If we see geometrically, we can assume that this function is not 1, 1, because they are repeating the values, the range values on the two distinct values. Like x1 is not equal to x2, but at both values, their uh, f of x1 is equal to f of x2. And such kind of function is 1, 1, where each distinct values from the domain, it will gives us the distinct values on the range, where domain is the all values along x-axis and the range all values on the y-axis. And So here, these are also the same definitions about the one and onto, which we have already seen. So there are some examples of functions which are given here, one and onto, which we have already seen. But I will share you on the portal. You can see and read these examples. Also, the compositions and their examples are available over that one, which I will share. And so there is also the there is a derivative test for which we can employ to see that this either function is one or not. So if f dash of x is less than or equal to 0 for all x, then it means such a function is decreasing, and we conclude that the function is 1 to 1, or 1 or 1 to 1 is the same thing. And the inverse function, as we also already described, that if a function is from a to b, then f inverse is a function from b to the a. And here we saw some examples that how to compute the inverse of a function. Like if f is a function going in this way, then inverse will be totally taking the opposite values. Like x-axis will become y-axis and y-axis will becomes x-axis. For instance, if f of x equal to x cube, then f inverse of x equal to the x power 1 by 3, just into its opposite form. So here these are also shows that how to find the f inverse for that function, and there are also some geometric form of these functions are available over there. Similarly, one can compute the, if f is available, so one can compute f inverse just taking the y equal to f inverse of x, and for solve that values we can compute this thing. And in general, if we have any function f of x equal to ax plus b, where a is any a and b are real numbers where a is non-zero, then f inverse of x equal to the 1 over ax minus b over a. So this relation is very important. Like if we compute the f inverse, so the value a must be non-zero, because a will comes into the form of a denominator when we compute f inverse. So there are certain properties of a the inverse function of that one. So inverse function is basically gives us the, when the function have a one correspondence, then it their inverse exists. So these are some geometric behavior for that one. So you can see this thing about that one. So there are some derivative tests, but these are just for the example purpose, and uh, you can you can study these things. But then what the derivatives tests are not included in the course, but this is just like for your practice, that you can see how the the inverse and how the function are defined on these sets. Okay, and the composition we also described, that we already saw that f is a function from a to b, and g is a function from b to c, then h is function from h is a function from c to d, then we can see its composition. And we need to see that this the associative law will always be hold in this case, like HOGOF is equal to HOGOF. So these kind of composition relations will always be the hold in that function. And the one and onto function, as we already saw their example, so these are already available in the this material which we already uploaded, and you can follow these also available in the tutorial later. So if f is the 1 correspondence, then f inverse is also 1 1. Give us a 1 1 correspondence, and it is 1 1 and onto. And then there will be some set equivalent form for which gives us the relation that if f is a function from a to b is 1 1 function, then the different element of a are mapped to the different element of b. The size of b is at least as large as the size of A. On the other hand, if f is onto, then since each element in B has at least one element in A that is mapped to it, so the size of B is greater than the size of A. Thus, the 1-1 correspondence provide us a means to to compare the size of sets. And so that's why we describe some equivalence relation of that one. But this kind of equivalence relations are not included in the course. Also, the cardinality will be not equivalent. The cardinality will actually gives us the size or equivalence relation of that one. So the syllabus will be till this part of the functions before the equivalence set. So these are the topics for the syllabus. And if we comes to the some problems which are related to the assignments, here you have a some set defined. F is a function defined as a f of x equal to 3x plus 1, and gx is also function from R to R defined as a gx equal to e raised power 2x. So need to determine the image of S, where S is some set of a real number. So also the other, we define the two functions and need to check that whether these functions are one-to-one correspondence or not. So one-one correspondence mean that need to check that these functions are one-one and onto or not. Because if the functions are one-one and onto, then it means these are one-to-one correspondence. So do you have any question? If you have any question, you can ask your question now. Yes, please. Hello. Yes, you can ask your question. Unmute, please, first, then.
Hello, sir. I just want to ask, when you say is a function that as fx is cos x minus I sin x, uh,
Yes.
where did you find the 2 pi in the equation?
Okay. Yes, you are asking about that one. So look, f is a function from R to set of all real numbers to the C. So 2 pi is also the real number because 2 pi is a the value like which is some real number. Like pi is equal to we know that which is equivalent to the 360 degree. And remember that the 2 pi and 4 pi, 6 pi, so these all are the real numbers. Okay, we are not saying that it's a rational or irrational number form, that is another thing, but these are the real number. So 0 is a real number. This 0 is belongs to the this set R. 2 pi is also belongs to the set R. And we need to check that for those values which are unequal, but their images will be equal. And here I think you can also find some other values for which they are equal. For instance, I think if you put the value the pi over here, we know that cos pi is equal to the 0. Pi is like 180 degree at cos or if we see the if we compute at maybe 90 degree, pi by 2. So at pi by 2, cos pi by 2 is 0 and sin pi by 2 is equal to 1. So it will becomes minus iota, like f pi by 2 is minus iota. And if you take f pi by 2 plus 2 pi again, then you will get again the same value, which is equal to again minus 1, minus iota. So it means that f of pi by 2 is equal to f of pi by 2 plus 2 pi. So hence it means we get the many elements that are unequal, but their images will be the same. Like f of 0 is same as f of 2 pi. So, so that's why we say that such a functions are not surjective or not one-one function. Yes, I hope it's clear. Any other question? And for the syllabus, so there will be, this is just like I shown the example, but for such a complex numbers, and these will be not the part of a syllabus. Okay, the functions defined on the complex values will not be considered in this course. And remember that one thing is important, that the typed assignment will not be accepted. Like, this is the decision from the department that some students are sending the submitting the assignments which are in the type form, like typing from the computer or some devices, and they just make its PDF and upload. So this will not be considerable. So please write the you must solve the problems and use your full efforts, and it will be the handwritten. Just make the scan of that pages and submit on the link of their before the deadlines. That's it. Any other question or comment if you want to ask? So you are welcome.
Sir,
Yes, please.
is it possible to get a list of the things that we shouldn't do, like the things that are not in the syllabus, posted on the
Look, in the
module?
syllabus things, in the like basically in the lectures, I will identify like the complex numbers are not included, and also the as the sets and functions. So all these things are already described in the tutorial letter, and you need to see the topics of the tutorial letters. And if there are something like, for example, the in the change the basis, so there are some things which will be not the part of that. So I already included. I will mention on that, as well as at the end I will make the list, or can write you that these things will be not part of the syllabus. So, but these all things are already explained in the tutorial letter.
All right, thank you, sir.
Okay, welcome. Okay, fine. If there is no any other question,
Sorry,
yes, please.
Professor.
Yes, please.
Hello.
Yes,
Yes. So, my question is based on the assignments. I noticed that when I downloaded the assignments from my UNISA, it appears differently. Some characters or notation is changed compared to the assignments that you're showing us now on problem two.
can
The
you
one that
okay, wait a second. Like, I think there will be no issue. It should be proper one. For example, if let me show you here, everything will be accordingly. But let me allow
Mhm.
to you that you can share your screen and show me that if there is something wrong, then we can see this. But this is also the important thing, that make sure that your network signal will be proper. And if there is any issue, then you can ask that, or just clarify that is this okay or not. But I think it will be the fine that you can uh, like the assignments will be uploaded on there, and you can download of that one. But I think everything will be fine over here, and you can simply download it, and the all questions will be appear properly.
All right, sir. Oh, all right,
Yes.
Professor. Because I had downloaded it before and completed the whole assignments, which is why the notations were different. And I had to keep on asking on the Telegram group about the notation because it was really
Yes,
confusing.
but
Maybe it has
sometimes if there is
changed
something, you can
now.
just attach the by email and ask me that this is the assignment. Like, I can reply you or
Yes,
clarify it to you.
Professor.
So
Yes, I did send you an email. It just never got replied, which is why um I went on to Telegram to ask the questions because I cannot
okay.
attach the assignments on Telegram, but I can attach the assignments on the email, on my student's email. So I did send you an email, but unfortunately I didn't get a
Yeah,
reply.
yes, I saw your question by the email. I received that one. I appreciate your question, but actually, that I want to clarify in the previous lesson. So that's why I was waiting. That should be identified in to the all students in the this session. So that's why I was waiting. Then when I saw your question again in the Telegram group, then I replied immediately. Okay, but I'm happy
All
that
right, thank
it's
you,
good you
Professor.
are asking the question. Okay, but your emails are always welcome. So. Hopefully, sometimes I will reply you immediately, but sometimes if I thought that it should be explained to all of the students, so then please be patient and I will explain such kind of important things or important questions of the students in the lessons. Okay, thank you. Is there any other question?
Sir, I just want to make sure. So, our assignment must be written and not typed.
Uh, can you please say again what you are saying?
Must our assignment be written and not typed?
Yes, yes, it is compulsory that the assignment, like there are, because this is good for you for your learning, and in the past time it was noted that the several students they make a copy, like one is typed and it's shared to other ones. The other one will be just write the name and that one. And one thing more important, I tell you that last year some disciplinary cases are appeared in a way that. There was some assignment there also the handwritten, but the different students submitted just on the top they write their own names, so this will also not be considered. So these assignments are actually for your practice based, and most of the things we have already discussed in the sessions, and but it's when you will do practice properly for your assignments, so definitely you will get the good grade in these courses. So my advice is that please you can be discussed with each other, but when you are writing the assignment problems, so please do it on your individually and confidentially, and do not share the other things to the other one, because in the two cases are in the past they are happening that one student if he typed and he shared to the other, so and just they change sometimes the format of the like font they change and submit. So that's why it is a decision that no typed assignment will accept it from any student. The secondly, if there will be found any plagiarism kind of thing, so there will be a disciplinary committee which is strictly asking that to be forward such kind of the thing of assessment, either be assignment or the any exam kind of thing. So then these are actually the instructions which we must need to follow. So my advice to you that please avoid to be the such kind of thing.
Thank you, sir.
Okay, welcome. So if there is no question, then we can close the session now. Many best wishes, and if you have any question, you can write by email and also welcome in the group. And one question I saw about the student, they are asking that about the study guide. Basically, for this course, there is no any study guide, but since I found the previous study guide for that one and I uploaded in the my module website, but just because the topics are some same like some topics of the vector spaces and subspaces, the basis dimensions. So you can just see some questions for the practice based, but officially for this course there is no any study guide. The textbook and these sessions are okay for this. Okay, best wishes, and we will see the next lesson about the vector spaces in the next session, and we will describe you about the and also the this video lecture will be shared on the my module website, and you can follow or you can download from there. Okay, goodbye and best wishes. Okay, bye.